Okay, next one, example 6. An object P of mass 0.5 kg hangs on a vertical tungsten wire of diameter 0.2 mm and the length of 1 meter. Hanging from the bottom of P is a copper wire of diameter 0.5 mm and length of 1.5 meter that supports an object Q of mass 0.35 kg. Assume that the elastic limit of the wires is not exceeded and both wires are massless, given the Young modulus of the tungsten and the copper, and also the gravity here. Okay, first sketch and label the free body diagram of the objects P and Q, and then determine the tension in both wires and the total strain energy of the system. Okay, first of all, we need to draw the diagram. Okay, sekarang ni kita ada dua objek, which is object P dan object Q. Okay, first we have object P, which hangs on a vertical tungsten wire. Okay, so let's say this is the support beam. And then kita ada tungsten wire, and then dekat bawah tergantungnya objek P, di mana objek P ni mass dia adalah 0.5 kg, and then the wire, so this is the tungsten wire with diameter 0.22 mm and the length of the wire is 1 meter. And then hanging from the bottom of P, so dekat bawah P ni, we have another copper wire. So we have another copper wire here that supports an object Q. So dekat bawahnya tergantung lagi object Q. And then object Q has a mass of 0.35 kg, and then the wire has a diameter of 0.5 mm and the length of this copper wire is 1.5 meter. And then we need to assume that the elastic limit of the wire is not exceeded and both wires are massless. So wire of the tungsten wire and the copper wire, kita boleh ignore the mass. Okay, now we want to sketch and label the free body diagrams of object P and Q. So object P here and object Q. Okay, kita label dahulu FBD. First object P. So apabila kita lukis FBD, remember we need to start with a dot. So start dengan dot dahulu. So this dot represents the object. Okay, untuk objek P, kita tengok dia ada wire, bermaksud akan ada tension force going upward. So going upward will be tension force T, and then ke bawah dia akan ada weight force, which is the weight force for the P, and also the tension wire from the copper wire here. So ke bawah dia akan ada weight force and also tension. So let's label this one TP, this one TQ. So ni adalah wire TP, maksudnya wire ni connected with the P, and this one TQ, so this wire is connected to the Q. Okay, so next one, object Q. Sama juga, kita akan start with a dot. So untuk Q, dia akan ada weight force going downward and also tension force going upward. So weight force, okay, let's label this one, and then tension force going upward, TQ. So this will be the FBD for the for the object P and Q. Okay, so lepas kita sudah ada FBD, we can determine the tension in both wires. Maksudnya kita mau cari TP and TQ. So for B, we want to find TP and also TQ. Okay, so we just assume this the forces here is balanced. Bermaksud the sum of Fy, since dia adalah vertical, adalah sama dengan kosong. Okay, kita keluarkan dahulu for the first one, object P here. TP minus TQ minus WP sama dengan kosong. So minus because they are both going downward. Okay, remember kalau pergi bawah negatif, pergi atas positif. So pergi kanan positif, pergi kiri negatif. So this one we have learned in chapter 4 before. Okay. So now we need to find these two value. Okay, kita susun dahulu TP minus TQ equal to WP, di mana this one kita boleh dapatkan which is equal to mg. So mg, the mass of the object P. So make sure kalau P dekat sini maksudnya mass of the object P 0.5 direct dengan gravity 9.81. So kita akan dapat it is equal to, okay, let me calculate that real quick. Equal to 4.905 Newton. So this one kita tiada lagi. So just leave it like that. And then next one kita keluarkan for object Q pula. Sama juga, it will be equal to 0. So untuk object Q kita ada TQ minus WQ sama dengan kosong. So dekat sini kita boleh dapatkan value untuk TQ which is equal to WQ, which is equal to mg. So mass of the Q 0.35, the gravity 9.81. So kita akan dapat tension for the copper wire equal to 3.43 Newton. So this one kita boleh dapatkan, kita boleh masukkan dekat sini untuk dapatkan TP. So TP adalah sama dengan 3.43 plus 4.905 equal to 8.34 Newton. Okay, next question. Determine the total strain energy of the system. So kita kena cari dahulu energy untuk object P dan energy untuk object Q, and then kita tambahlah because we want the total energy. Okay, so here B2 we want to find the total energy, di mana total energy adalah energy Q tambah dengan energy P. So energy Q adalah sama dengan 1/2 Fe, and then energy P juga sama dengan 1/2 Fe. Okay, so in order to find this value, okay, let's identify, do we have the value of the F and the E here? Okay, F kita ada, force kita ada, which is this one. Okay, these two value is the force, we have it, but we don't have the value for E. E adalah elongation. So setiap wire ni dia akan elongates. This one pun dia akan elongates. So we need to find that value of E first. So how do we find this? Kita gunakan formula untuk Young's modulus. Okay, so since kita sudah dibagi Young's modulus for each of the material, so keluarkan dahulu untuk Q, YQ, which is equal to FL0 divided by AE. Okay, so Q tadi, the material is this one. What is the material here? Is the copper, which is equal to 1.2 exponent 11 Pascal. 1.2 exponent 11 Pascal. And then the force here will be WQ. WQ is this one, 3.43 Newton. Okay, WQ 3.43 Newton. And then the original length of the the copper wire is 1.5 meter. 1.5 meter divided by the area. Area adalah pi d square. Pi d square divided by 4. So diameter of the wire here is this one, 0.5 millimeter. Then times with E. So elongation of the Q1 is equal to 2.18 exponent -4 meter. Okay, let me double check that one first. Okay, don't forget the square here. Sorry, I forgot to put the square. Okay, so it will be equal to 2.18 exponent -4 meter. So this one adalah untuk YQ. Now untuk P. So YP gunakan formula yang sama. FL0 divided by AE. So P tadi kita gunakan, the material here is tungsten. So this is the value, 3.6 exponent 11. 3.6 exponent 11 equal to the force of the P, which is, where is it? This one. Okay, WP adalah sama dengan mg, mass of the P times with gravity. And then the original length of the wire, P adalah 1 meter divided by area. Area sama juga, pi over 4 times with diameter. Okay, diameter is this one, 0.22 meter. Okay, square, and then times with elongation. Elongation is equal to 6.09 exponent -4 meter. Okay, so now kita sudah dapatkan elongation, so we can find this value for energy. So energy for Q 1/2 Fe. F tadi adalah 3.43 times with 2.18 exponent -4. So UQ is equal to 3.74 exponent -4 joule. Then UP half F. F tadi adalah this one. And then times with the elongation. So you will get UP is equal to 2.54 exponent -3 joule. So total energy kita just tambah 3.74 exponent -4 plus 2.54 exponent -3. So sama dengan 2.91 exponent -3 joule. This is the final answer.